Good morning students. Today in this video lecture we will discuss Chi-Sqaure test. Chi-Sqaure test is a non-parametric test. The non-parametric tests are increasingly gaining importance in business research because they are distribution free. That is, they can be used with any shape of population distribution and they are easier to handle and understand as compared to parametric test. Further, they can be used with type of measurements that prohibit the use of parametric test. The Chi-Sqaure test describes and explains the magnitude of discrepancy between theory and observation. It is symbolized by Greek letter chi and the formula is the summation of fraction, that is O minus E whole square in the numerator divided by E in the denominator. Conditions for Chi-Sqaure test. Point number 1. The number of observations must be reasonably large to ensure the similarity between theoretically correct distribution and the sampling distribution of Chi-Sqaure statistic. Point number 2. No theoretical cell frequency should be small when the expected frequencies are too small. The value of Chi-Sqaure will be overestimated and will result in too many rejections of the null hypothesis. In case the cell frequency is less than 5, then Yates correction is to be applied. The uses of Chi-Sqaure test are of paramount importance. Point number 1. It is used as a test of population variance. Point number 2. It is used as a test of independence. That is, with the help of Chi-Sqaure test, we can find out whether two or more attributes are associated or not. Suppose we have n observations classified according to some attributes. We may ask whether the attributes are related or independent. Thus, we can find out whether the medicine which is to be given to the patients is effective in controlling a particular disease or not. Point number 3. It is used as the goodness of fit. Chi-Sqaure test is very popularly known as the test of goodness of fit for the reason that it enables us to ascertain how appropriately the theoretical distribution such as binomial, Poisson or normal distribution fits the empirical distribution. And the last point, it is used as the test of homogeneity. The Chi-Sqaure test of homogeneity is an extension of the Chi-Sqaure test of independence. The tests of homogeneity are designed to determine whether two or more independent random samples are drawn from the same population or from different populations. Now, with the understanding which we have gained in the earlier part of this video, we'll solve few numericals. On your screen, you have question number 1, which details that a sample of 12 students drawn from a normally distributed population shows a variance equal to 36. You are required to test that the population variance is equal to 42 using 1% level of significance. So students, please understand what you are given in the numerical. You are given certain values and let's say we try to summarize them for your reference. The number of observations are equal to 12. The sample variance is equal to 36. And the population variance which you are required to validate is equal to 42, and you have to test the entire situation at 1% level of significance, that is the value of alpha is 0.01. Continuing with the solution of this numerical, students, will firstly frame the null hypothesis, and for your reference, null hypothesis is abbreviated as H0. So we'll frame the null hypothesis for this numerical, that is the population variance is equivalent to 42. Further, we'll calculate the value for Chi-Sqaure using the formula, that is n times the sample variance in the numerator will be divided by the population variance. So what we'll do now, students, we'll substitute the values as given in the numerical. The value for n is 12, so we substituted here. The value for the sample variance is 36, so we substituted in the numerator part, and in the denominator we substituted the value for population variance equivalent to 42. When 12 is multiplied by 36, it leads to a value equivalent to 432, and when 432 is divided by 42, it results into a value equivalent to 10.28. It means the chi-square calculated value is equivalent to 10.28. Further, the degree of freedom, which is abbreviated by DF, is calculated by reducing 1 unit from the number of observations. It means 12 minus 1 is equal to 11. Now we will calculate the chi-square table value. The chi-square table value is calculated for a particular degree of freedom and for a particular level of significance. In this case, the degree of freedom is equal to 11 and the value for alpha is equal to 0.01. Therefore, the chi-square table value for degree of freedom equal to 11 at alpha equal to 0.01 is equal to 24.72. Students, kindly note that the calculated value of chi-square is less than the table value, which means the supposition or the golden rule is validated in this case. That means when the chi-square calculated value will be less than the chi-square table value, in all such cases the hypothesis will be accepted. So in our case, the chi-square calculated value, that is 10.28, is less than the chi-square table value, that is 24.72. Thus it can be concluded that H0 is accepted in this case, which means that the population variance is equal to 42. Continuing with the numerical part, now we'll solve question number 2. Question number 2 relates to the data which specify that the treatment of 250 patients suffering from a disease, and what you are required to, on the basis of the table which is given below, you are required to state whether the new treatment is superior to the conventional treatment. Students, kindly note that this is the categorical data in the tabular form which is given to you, where patients are being classified with respect to the treatment, that is new and conventional. So in the initial step, we'll calculate the expected values. And students, for your reference, in general, the expected frequency of any cell can be calculated by the formula, that is the row total for the row containing the cell is multiplied with the column total for the column containing the cell. This product value is divided by the total number of observations. So we use the same formula. What we did, for this very cell, the total value for the column is 200, so we wrote 200, and for this particular cell the row total is 170, so we wrote 170. So we multiplied 200 with 170 and divided this by the total number of observations, that is 250. So what it means, when 200 is multiplied by 170 and the product value is divided by 250, we get a value equivalent to 136. Likewise, for all other cells we calculated their expected value. Further, what we will do after calculating the expected value, students, we will firstly write the null hypothesis. Null hypothesis is abbreviated by H0, as you may remember. And null hypothesis in this case is there is no significant difference between new and conventional treatment. Now, moving to the solution in numerical terms for this particular question, what we'll do, we'll write the observed values and expected values. So for your convenience, I have written the observed values row wise and the expected values which we have calculated just now in the row sequence. Now what we'll do in the next step, we'll calculate the difference of O minus E and we'll square the difference. So when 140 minus 136 leads to a value equivalent to 4 and the square of 4 is equal to 16. Likewise, when 64 is reduced from 60, it results into a value equivalent to minus 4 and the square of minus 4 is 16. Further, when 34 is reduced from 30, it leads to a value equivalent to minus 4 and the square of minus 4 is 16. Lastly, when 16 is reduced from 20, it results into a value equivalent to 4 and the square of 4 is equivalent to 16. So what we have done, students, in this particular column, we have calculated the value of O minus E whole square. Now in the last column, what we will do is we will calculate the value of fraction, that is O minus E whole square in the numerator will be divided by the expected value in the individual sequence. That means in the first row 16 will be divided by the particular corresponding expected value, that is 136. So it means 16 divided by 136 is equivalent to 0.11. Likewise 16 divided by 64, that is the corresponding expected value, is equivalent to 0.25. Further 16 divided by 34, that is the expected value in this case, is equivalent to 0.47, and in the last part 16 divided by 16 is equivalent to 1. Students, now we will summate all these values which we have calculated in the last column, that is 0.11 plus 0.25 plus 0.47 plus 1, and the summation of this will lead to a value equivalent to 1.83. So we can summarize this that the chi-square calculated value is equivalent to 1.83. Further, we'll calculate the degree of freedom. In case of a categorical data, the degree of freedom will be calculated by multiplying R minus 1 with C minus 1. In this case, the number of rows were equal to 2 and the number of columns were equal to 2. So 2 minus 1 into 2 minus 1. 2 minus 1 is 1. Again 2 minus 1 is 1. When 1 is multiplied by 1, it results into the degree of freedom equal to 1. So we'll now calculate the table value. The chi-square table value for degree of freedom equal to 1. Students, kindly note that the level of significance was not given to us in the numerical. So as a general rule, we are solving this numerical at 5% level of significance. Therefore, the chi-square table value for degree of freedom equal to 1 at alpha equal to 0.05 is equivalent to 3.84. Students, you are requested to revise and remember the golden rule. That is, if the chi-square calculated value is less than the chi-square table value, then in such case the H0 will be accepted. So let's say we apply the same rule in our case. The chi-square calculated value in this case is equivalent to 1.83 and the chi-square table value in this case is 3.84, which summarizes that the chi-square calculated value is less than the chi-square table value. Therefore, the null hypothesis framed is accepted for this particular numerical, which concludes that there is no significant difference between the new and conventional treatment. Further, in the previous video, yesterday we talked about the association of attributes and we talked about various methods to deduce the association of attributes. Now, the last method in association of attributes is coefficient of contingency. The coefficient of contingency is symbolized by the capital C and is given by this expression, that is the square root of the fraction, which is chi-square in the numerator, will be divided by the addition of n plus chi-square, where capital N is the number of observations. So students, in question number 1 which we have recently solved, the value for chi-square is equivalent to 10.28 and the number of observations in the numerical 1 is 12. So we'll apply the formula of coefficient of contingency and we'll calculate its value. So after substituting the values of question number 1 into the journal formula for coefficient of contingency, we'll get an expression of this kind. Solving this expression further, in the denominator part, 12 plus 10.28 is equivalent to 22.28. And when 10.28 is divided by 22.28, it results into a value equivalent to 0.46. And the square root of 0.46 is equivalent to 0.67. Likewise, for question number 2, we'll again find the coefficient of contingency and we'll relate these two. In question number 2, the calculated value of chi-square is 1.83 and the number of observations are equivalent to 250. So we'll again substitute the values in the general formula for coefficient of contingency, and we'll get an expression of this kind in the mathematical form. Solving this mathematical form further, when 1.83 is divided by 251.83, we get a value equivalent to 0.007, and the square root of 0.007 is equivalent to 0.083. Students, kindly note that when the chi-square calculated value is of lower order with the given higher number of observations, the coefficient of contingency will tend to decrease. I hope in this video lecture you must have gained the knowledge regarding chi-square test, and you must have revised the meaning and uses of chi-square test along with the numericals. Thank you and have a nice day.